example, gigabit Ethernet, let me write here, gigabit Ethernet, I can understand that you are talking about the IEEE 802.3ab. This is the standard of the IEEE for forwarding the Ethernet frame on the copper, and also we have another standard IEEE 802.3z. We can use it for forwarding traffic with 1000 megabit per second or 1 gigabit per second over a fiber link. Both of them are using the gigabit Ethernet links, or you can say 10 gigabit Ethernet, 40 gigabit Ethernet, 100 gigabit Ethernet. Okay, because of that, in most cases when we are talking about the Ethernet speeds, we don't use IEEE 802.3, for example. We say Ethernet. When we want to talk about IEEE 802.3u, we don't say IEEE 802.3u. It's different. Okay, it's difficult. We can say fast Ethernet, it's easier. For example, if in future you will learn on the switch, we have some interfaces. Assume that this switch is using the IEEE 802.3, or for example, U interfaces, means 100 megabit per second interfaces or ports, 100 megabit per second ports or interface. This is the interface or port. When we are configuring, we don't say the interface or port 802.3u. We say interface fast Ethernet. That's it. So easy. Okay. Because of that, it's better to knowing about these terms. You will encounter with these terms. You will hear fast Ethernet. You will hear gigabit Ethernet or 10 gigabit Ethernet. For example, you know that we have one standard IEEE. I showed you in the previous video at 802.3ae. All of them are starting with the IEEE 802.3 because this is the Ethernet standards. And after that, we can say for example, this is the 10 gigabit Ethernet. Because of that, when you say 10 gigabit Ethernet, we have 10 gigabit Ethernet. I can understand that you are talking about the IEEE 802.3ae, for example. When you say we have gigabit Ethernet, I can understand that you are talking about the IEEE 802.3ab. And because of that, we have another terminology about these different Ethernet types. Another important things about the Ethernet is that all of the Cat3, Cat4, Cat5, Cat5e, Cat6, Cat6a, Cat7 and Cat7a's cables only are supporting 100 meter. And if you are, for example, you need to extend more than this distance, you need to use for example, switch or repeater or hub between two devices. Look at here, the distance between the PC1 and switch 1 cannot be more than 100 meter. Okay, because the twisted pair in all of its categories only can support 100 meter. For example, Cat3, Cat5 or more than this. Okay, but about the fiber link, as I mentioned before, if you are using, for example, short wavelength, means the for example SL links. Okay, we are using we have, for example, 2 kilometer or in some cases 400 meter. Okay, this is different about the networks, about the cable types. And when you are using, for example, long wavelength, you have more than 2 kilometer or, for example, 4 kilometer or maybe 10 kilometer. Okay. As you remember, in the previous video, I mentioned that we have three type of wavelength. The first is a small or short wavelength, the second is long wavelength, and the third is an extra long wavelength. And when you are using the for example, copper cables, means twisted pair cables, only you have 100 meters of the extension. For example, between the PC1 and switch 1, we have only 100 meter distance. If you have more than 100 meter, you need to, for example, use the fiber, or maybe you can add another switch here between the PC and the new switch, for example. Very good. Now let me to talk about a little more than this, about the detail of the twisted pair, about the connectivity. You know that until now we learned about the twisted pair cable, about the categories, about the insulation types, okay, and after that different speeds and some standard codes, some terminology and some other detail. But now I am going to give you more information about the twisted pair cables, specifically about how we can connect, for example, two switch to each other with the twisted pair cable, or how we can switch one. We can connect one switch to one PC, for example. But before that, let me to show you one interesting scenario. Look at here. Again, we are using the packet tracer. I'm going to connect two switch with each other with one fiber link. Here we have a switch. Let me to use one switch. This is a switch. I'm going to use one of the switch. This is switch 1. This is switch 2. You know that, and if I want to connect these two switch to each other with a fiber, here we have fiber. Look at here, this is a fiber, as you can see. But if I choose this fiber and try to connect this switch to other switch, I can't, because here, as you can see, we have only all of them are RJ45, as you can see in the symbol. We can't connect this fiber to the for example, to this interface. Look at here, if I select it, I will receive one error message. The cable cannot be connected to that port. We need first to add some SFPs or some fiber ports to this switch. The detail is not important for you now. Only you need to watch, and this is one experience for you. Look at here. Let me to click on this switch. Now here we have some components. Okay, this is the front panel of the switch, as you can see. I'm going to add one of these interfaces to this switch. This is our switch, and here, as you can see, we have 4 empty ports. Okay, 4 empty slots. Here we have a fiber link port or one SFP. Let me to click it and drag it here. Now I added one of these SFPs here. Because of that, now we can use this switch for connecting the fiber link between this switch and another switch. In the next switch, again, we need to do the same things here. Maybe this is interesting for you. Okay, now we have one fiber link here. Now, if you want, you can select the fiber link and click on the switch. Here we have an option. Okay, let me to show you. This is the option we have here. As you can see, this is a fiber link, and now we can connect it to the next switch. That's it. Okay, you will learn about this, don't worry. But for now, as you can see, I added one fiber link, one for example converter, and after that I connected these two switches to each other with the fiber link. Okay, but now let me to talk about more than this, about the twisted pair cable. Twisted pair cable is so important for us because we are using in most cases the twisted pair cables between the two switch, between a switch and router, between a switch and PC. Okay, now I'm going to talk about the detail of connectivity. This is a practical task, and after this part we can connect the PC to switch and also the switch to router, and we can better understand the different types of the twisted pair cable. For example, we have one type of twisted pair cable, we call it straight through cable. We have another type, we call it for example crossover cable, and we can use this type of cables to connect devices to each other. As you can see in this picture, we have a twisted pair cable. This is a twisted pair cable, and here, as you can see, we have 8 wires and 4 pairs. Okay, the 4 pair with different colors. For example, here we have blue and then white blue. Here we have green, orange and white orange. Here we have green and white green, and finally brown and white brown. In twisted pairs, twisted pair cables or wires, we are using 2 type of colors. The first type of color is the solid colors, as you can see, brown, then for example green, then orange, then blue, and after that the other colors are stripped colors. For example, white green, white orange, white blue, white brown. Okay, you know that we need to connect or crimping this cable, these wires into the, for example, RJ45 connector. This is the RJ45 connector. This is the up of the RJ45, and this is the another view of the RJ45. Here you can see that we have 8 pins. Each of these 8 pins should connect to one of the one of these wires, and finally we can connect this cable to a interface, for example to a switch or to a interface or a port of the Ethernet in our computer. Look at here, this is a network interface card or gigabit network interface card. You know that we are using this card in our PC. We can connect this network interface card to the motherboard of our PC with PCI connection or some other type of connection. After that, it can give us one Ethernet port. We are connecting the Ethernet port, this Ethernet port, to the keystone or to the network with these cables. We call these cables the patch cord cable. Look at here. Here we have a patch cord cable. What is the patch cord or patch cable? It's so easy. As you can see, we have a cable. In two sides of this cable, we have two RJ45 male connector. One of them should connect to this switch port, to this Ethernet port, and another can connect, for example, to switch or other devices. And because of that, we can create a network easily. Let me to give you one example in our simulator. This is our simulator. Here I'm going to add one PC to these networks. Here I added these two switch, or I connected these two switch with one fiber cable. If you want, you can use another cable, for example the twisted pair cable, but for now I'm going to add two PC. This is the first PC, this is the second PC, and then I'm going to use one patch cable. This is a patch cable. Look at here, this is a copper cable. I will talk about the